Have you ever wondered what's really going on inside a sophisticated AI? Well, today, we're going to peel back the curtain. We're not just talking about concepts, we're looking at the actual engineering blueprints that developers use to build these incredibly smart agents. So let's just start with the big question right away. How does an AI really solve a complex problem? I can tell you it's definitely not magic. It's all about engineering, using a set of powerful, repeatable solutions that basically act as the architectural plans for intelligence. And these solutions have a name: Agentic AI Design Patterns. You should think of them exactly like the blueprints for a skyscraper. They are the structured, proven designs for creating AI systems that can actually reason, plan, and get complicated stuff done. All right, so where do we even begin with all this? Well, you start with the foundation, right? The simplest, most fundamental pattern of them all, which you can think of as the assembly line of AI. And the source material here gives us the absolute perfect way to picture this. It's just like a factory assembly line. Each station does its one specific job, checks its own work for quality, and only then does it pass the item on down the line to the next station. This pattern is called prompt chaining, and the whole idea is to take a huge, messy task and break it down into a sequence of smaller, much more manageable steps. But here's the most important part. The output from one step is validated before it becomes the input for the next one. This is so key because it builds quality control right into every single stage of the process. Now, if you look at how this works, it's pretty brilliant. You get a request, you break it down, you do the first part, and then boom! You validate the output. Did it work? Is it good enough? This step-by-step check-in is what catches failures early and stops a tiny little error from snowballing and ruining the entire final product. But, like any design, there are trade-offs. On the one hand, it's super modular and fantastic at catching mistakes. But on the flip side, if you keep passing too much information from step to step, you get this thing called context explosion. Basically, the process gets slow, it gets expensive, and it can even increase the risk of the AI just making things up, what we call hallucinating. Okay, so that's our assembly line. But what happens when a problem is just too complicated for one single process? What if you need different kinds of expertise? Well, then you build a team. And this brings us to our next pattern, which is probably easiest to understand if you just imagine a really smart receptionist, someone who listens to what you need, figures out what you're really asking for, and knows exactly which person to send you to. This is a pattern called routing, and it's essentially an AI that acts like an intelligent traffic controller. It looks at a request, analyzes it, and sends it to the right specialist. So, for example, if you ask a chatbot about your bill, it doesn't get sent to the tech support agent. Routing makes sure the right expert is always on the job. Okay, but what if you have a massive job that needs to get done right now, fast? Well, that's where another team pattern comes into play. Imagine you need a book summary. You could read it yourself, or you could get 10 people to each read a different chapter at the exact same time, and then just combine all their summaries at the end. That's parallelization. The system takes a giant job, splits it up into a bunch of independent chunks, and then assigns those chunks to multiple worker agents to process all at once. This is how AI can tackle enormous tasks, like analyzing millions of data points or scraping the entire web with incredible speed. Then it just stitches all those pieces back together into one coherent report. So, we've got an assembly line and a team of specialists. That's a great start. But for this team to be really effective, they need two more things: a good toolkit and a memory. So, to understand how these agents use tools, let's start with this great analogy. Think about a chef. They know they need certain ingredients for a recipe, so they check the pantry to see what's actually available, make sure it's good to use, and then grab it to start cooking. This is what gives AI agents superpowers. The tool use pattern lets an agent find and use external tools, things like a web search for up-to-the-minute information, a calculator for perfect math, or a database to pull specific customer data. It literally connects the AI to the outside world, letting it overcome its built-in knowledge limitations. And what about memory? Well, the best way to wrap your head around this one is to just think about our own brains. We keep track of information in different ways, right? Some things we only remember for a second, some are specific events from our past, and other things become permanent knowledge. AI agents do the exact same thing with a system called memory management. It classifies information as short-term, episodic, like remembering a specific event, or long-term knowledge. This is absolutely crucial for creating personalized, context-aware conversations, like a customer service bot that actually remembers what you talked about last time. All right, we have our foundation, our team, our tools, and our memory. Now it's time for the master plan, putting everything together into one big, coordinated system. The best analogy for this is a film crew. You've got the director, who's coordinating the whole show, and then you have specialists for camera, for sound, for lighting. They all handle their own part, but they're all working from the same script and the same schedule to create one single cohesive movie. And that, right there, is the heart of multi-agent collaboration. It's the top-level pattern where you have multiple, specialized agents all working together on a massive, complex project. They're all coordinated by a central orchestrator agent and usually share a common memory to make sure everyone's on the same page. This is how AI can tackle truly huge, multifaceted goals. So here's the takeaway. We've literally gone from a simple, single assembly line all the way up to a fully coordinated team of specialists with external tools, a shared memory, and a director running the whole show. These aren't just ideas. These are the fundamental blueprints for building truly intelligent AI. And that just leaves us with one final, fascinating thought to chew on. If these are the blueprints that engineers are using to build AI right now, today, just imagine what incredible AI structures they're going to build tomorrow.